Right? This is 11.5, reference angles. I'd like you to take a second, pause the video, and use your calculator to find all of these values in front of you to the nearest thousands. Okay? Now that you're back, 0.866 is the first one. So 0.866 is the sine of 60. If you did not get that, then please make sure, like, you should have typed sine 60, enter. If you didn't get that, please make sure you are in degree mode. So remember, in the calculator, you just hit the mode button, and then you just make sure that degrees is highlighted. I think it's the third line down, and not radians. Okay? So then the sine of 120 is 0.866. That's interesting. Two different numbers, same answer. Cosine of 45, 0.707. Cosine of 315, 0.707. Same answer, two different angles. Tangent of 110, negative 2.747. Tangent of 290, negative 2.747. So that's a really interesting concept. And the reason that this is possible, how is this possible, is because of something that we call reference angles. A reference angle is an angle that is a positive acute angle formed by the terminal side of the given angle on the x-axis. That's really exciting. It's things you have to remember. It's an acute angle. And also very important, that is always a positive acute angle formed by the terminal side of the given angle and the x-axis. Okay? These reference angles allow us to see places that the sine is the same in one quadrant, the sine of 120 is the same in one quadrant, as the same as the sine of 60 in the other, because of reference angles. And you'll see as we go where this comes from. So every angle has a reference angle. The only one, okay, and there's always an exception to that rule, to the every, is quadrantal angles. Just as a quick reminder what quadrantal angles are, they are multiples of 90. So 0, 90, 180, 270, 360, 450, etc., etc. Okay. And in case you forgot, acute angle, remember an acute angle is not just a really adorable angle, but it's an angle that is less than 90 degrees. Less than 90 degrees. Okay. Reference angles appear in all four quadrants. So maybe you remember, when we sketch angles, we always start in the first quadrant. We always start on the positive x-axis. Reference angles don't do that. They're special angles, and you actually draw each one in separate quadrants. And just as, FYI, quadrant 1 angles are their own reference angle. Just when you come back and when you go back and you want to read your notes, because I know you all do all the time. All right, so reference angles are formed by the terminal side. So remember, the terminal side is the sides that's always sticking up. These are your terminal sides. Okay, by the terminal side and the closest x-axis. So this guy right here is the reference angle. This is the closest x-axis. Okay, so that is your reference angle. That's it. So if we have 120 here, this is 120. The reference angle for 120 is 60 because the terminal side with the x-axis, that was a degree of 60. Because this whole thing, I got this. The whole thing from here to here is 180. So since part of it's 120, the other part is 60. Okay? Right. Similarly, in quadrant 3, you have this big angle here, 240. 240 degrees, the reference angle, the closest x-axis, goes back to 180. So if you want to think about this, you actually have to cut out this much of the angle. So you have to subtract 180 to figure out the reference angle. So it's 240 minus 180 to figure out this guy. So, you know, if you want a mathematical way. So remember, it's always formed by the terminal side and the closest x-axis. So be careful. There's things that some people do, you know, that isn't the x-axis, and you want to be careful. Always the x-axis, terminal side, x-axis. They say if I say it like 7 times, you'll remember. So terminal side and the x-axis. Okay, so in quadrant 4, so if we're in quadrant 4 here, right here with this angle, this big 315 degrees, the closest reference angle is this one. The closest x-axis is the positive x-axis. So I actually have to complete the circle. So this is 315 degrees. I have to, you know, figure out what's left of 360 degrees. So to do that, it's 360 degrees minus 315. So that would be 45 degrees. So that's the different reference angles. Remember, quadrant 1, it's its own reference angle. Quadrant 2, you subtract from 180. Quadrant 3, you subtract 180 from the angle. And quadrant 4, you subtract the angle from 360. I have it all written down on one of the next slides. So if we just look here, can you label the reference angle? So take a second and pause this guy and say if you can just draw where would the reference angle be. Not what is it, where would it be? Pause, come back. Okay, so the reference angle would be, this is the terminal side, so right here. This is the terminal side, so closest x-axis. This is the terminal side of this angle, closest x-axis. It doesn't matter like the whole loop-de-loops for the triangle. I mean for the angle that you make. What matters is, this is the reference angle right here, the terminal side and the x-axis. So it didn't matter if this angle to begin with was like this and went around 75 times, okay? The reference angle is going to be the exact same thing, okay? It's going to, the terminal sides are the same. Remember coterminal angles, it's always the same. So the reference angle, terminal side, x-axis. Okay, can you find the reference angles without having the little graph? So, first thing you have to remember, reference angles are positive and acute. Positive and acute. So if you have an angle that's positive and acute, it's already a reference angle. So this one, done. 50 degrees is the reference angle. It's positive and it's less than 90. 250. Well, where are we when we're in 250? I do like to draw these out because I'm weird. Okay, so 250 is in quadrant 3. So quadrant 3, we have to get back to the x-axis. So we have to cut out the 180 up here, so I need to subtract 180. So I subtract 180. 70. Wish you guys were here to tell me if I was right. Yeah, so 70. All right. Number 3. Now we're dealing with radians also. So you should convert. All right. So on the next slide, I can't go to the next slide because then it just like erases this slide. So if you look at the next slide, there is a how to find a reference angle little section. So the basic idea is convert if you haven't already. So remember, multiply that by 180 over pi. And it turns out to be 510. All right, you want to get an angle that's between 0 and 360 to do reference angles. It's just easier. Okay, so find a coterminal angle that's between 0 and 360. So subtract 360 or add 360 as many times as you need to for that to happen, and you get 150 degrees for this one. So 150 degrees is over here in quadrant 2. All right, so the closest x-axis is the 180 degrees x-axis. So I do 180 minus 150, and 30 degrees is my reference angle. Okay. The only problem with that is, with 30 degrees, is the question was asked in radians. So if the question's asked in radians, the answer has to be in radians. So just be careful of that when you're doing these. So then I would have to convert this, and when you convert 30, it is pi over 6. Okay, so take a second, do these guys, and I'll give you the answers. All right, here are your answers. Your answers are pi over 3. It was 60 degrees. You really didn't have to do all that work. If you knew it was negative 60, then 60 is the reference angle. So pi over 3. This one I just added 360, got 60, and that was done. And then this one I got 40 as my reference angle, which is 2 pi over 9. All right, so here's where I said, I'm sorry, it's a little small on yours, but you have good eyes. So these are the, right here, this is how to find a reference angle. Find the reference angle. Put the angle in degrees, if it isn't already. Find a coterminal angle between 0 and 360, so add or subtract 360. If you're in quadrant 1, you're done. Quadrant 2, 180 minus the angle. Quadrant 3, the angle minus 180. And quadrant 4, 360 minus the angle. Okay, and if they want you to be in radians, put it in radians. Okay, so how are we going to use this? We're going to find equivalent values today. And we're going to be using this throughout the rest of the unit. This is just the essence of trigonometry right here, is equivalent values. So right in the beginning with that do now, you saw that the sine of 120 is the same as the sine of 60. Okay, so that's what we're going to do, those kinds of things. All right, I call this the box, line, box method. It's coined by, probably Mrs. Schultz coined it, but it's box, line, box. So what you do is you figure out the quadrant that you're in. Okay, so you remember from yesterday this thing. All students take calculus, is the way I'm sure you all remember it. Depending on what quadrant you're in, cosine of 280 is going to be positive or negative. Okay, so the cosine of 280, so what quadrant are we in? With 280, we're down here in quadrant. This is 180, 270, so 280 is right here. So we're in quadrant 4. Cosine is positive in quadrant 4. So since cosine is positive in quadrant 4, I'm going to use a plus sign right here. So this first box is for the quadrant. Okay, I don't know what's going on there. Okay, it's positive or negative depending on the quadrant. I wrote it right here. Just read that. Okay, the line here is just saying put this right there. So if this says cosine, you put cosine there. If it says sine, you put sine, and so on. Now for this last box, you simply find the reference angle of 280. So what's the reference angle of 280? Well, we're in quadrant 4, so we do 360 minus 280, and that's 80. Done. So the cosine of 280 is equivalent to the cosine of 80. Done. That's an equivalent value. Now, if you actually type those in the calculator, you'll see that the values are exactly the same. Now, this is going to serve more of a purpose in the future, you'll see. Okay, do the same thing here. So we have 5 pi over 9. That's great and all. We should convert that to degrees. So I'm going to quickly convert it to degrees. This is the cosine of 100. So what quadrant are we in when we're 100? We're right here. We're in quadrant 2. So quadrant 2, the only thing that's positive there is sine and cosecant. That is not cosine, so this guy is going to be negative. Okay? So it's generally always going to be negative unless we're in the right letter. Since this is 100, we know it's quadrant 2, so it's 180 minus the angle, or 80. Okay, that's great and all, but that's degrees. This is degrees. This is radians. If the question is in radians, the answer should be in radians. So you do have to convert that to radians. Fairly certain it's 4 pi over 9. So this is negative cosine of 4 pi over 9. That's an equivalent value. Done. Okay, try a few of these on your own, and then I will go through them with you. So pause it, try the other 3, see what happens. Oh, that's so wrong. So this one would be negative sine of 70. Okay. Now, remember, negative 110 is down here. Whatever, I can do this. There you go. It's a negative 110 because we're going down. So the reference angle here, it's negative 110. So we add 360 to get within 0 and 360 to follow our regular rules. Those of you, maybe you can see that I just want to get to 180, so it's just going to get to 70. 70 plus 110 is 180. However you want to do it is fine. But if you want to keep a regular thing that you do all the time, negative 110 plus 360, it was what, like 250? So 250 is going this way, but it's just a coterminal angle, so it doesn't matter. The sides end in the same spot. They will have the same reference angle. So then 250 minus 180 is 70. However you want to work it. Okay, here 11 pi over 3, that's 660 in degrees. And that winds up being equivalent to negative the tangent of pi of 60, or pi over 3. And then lastly, the sine of 225. We are in quadrant 3, so sine is negative. And the reference angle is 45 degrees. So we'll do a little bit more of this in class tomorrow. I hope you understand it. Have a great day. Bye.